when we have a Bernoulli trial, this isn't a big part of what we're doing. Josh, can you close your computer for me, please? It isn't a big part of what we're doing, but it is kind of the overarching idea of this whole binomial and geometric distribution that we talk about in the next two lessons. The first thing that it kind of does is it's going to separate into two possibilities, but both of these possibilities share three common traits. So they both have to have, for a Bernoulli, you have to have two possible outcomes. Generally, we consider that to be success or fail. So whenever you're doing this, you're looking for one trait. You can't ask the question of like, what's your eye color? And then people respond blue, green, brown. You need to ask questions like, do you have brown eyes? And then people answer yes or no. So it's either a success that you found someone with brown eyes or a fail that you found someone that didn't have brown eyes. The probability of success must be the same for each trial, and the trials are independent. These two things kind of work together naturally. If I have independent trials, that means that one isn't necessarily affecting the other. And so because of that, the probability ends up being consistent. So these three traits that are listed here as a Bernoulli trial have to happen for binomial and geometric distributions. Now, the fourth thing is kind of what determines which one you actually end up doing. For a binomial distribution, you must have a fixed number of trials. Basically, you're going in, you're picking 20 people, you're shooting 10 darts, you're kicking 15 soccer balls. You're doing something for a specified number of times. And then you're looking at, within that fixed number of trials, how many successes do you want? Do you want 5? Do you want 10? Do you want all successes? Do you want all fails? That is a binomial distribution. The geometric distribution, again, has all three of these qualities, but the fourth thing that it's after is you're interested in going until the first success. So questions like, what is the probability it takes kicking the soccer ball 10 times before you get a goal? And so that would be a geometric. Now, we're not going to really mess with geometric today because that is going to be our last lesson of this unit when we come back from Thanksgiving break. But we're really going to focus on binomial. There is a way to do it by hand. The formula is going to be on your formula sheet, and then there's going to be a way in your calculator. So we'll kind of talk about both. So just to kind of specifically reference this in terms of binomial distribution, I use the acronym, and it's a common acronym in all AP classes, where we talk about BINS. Binary, independent, number of trial, same probability. So if you're on the AP exam and you write out the word BINS, it's common knowledge as to what it is. You don't necessarily have to go in and define what those mean. So what it kind of stands for. Binary is the condition of having a success fail. So what we kind of just discussed, again, successes in stats don't always mean the positive outcome. It sometimes means the negative, like you're trying to see, did someone die from heart failure? That would make it a success. Now, in the I part, for independent, each trial has to be independent of the next. A lot of things, it's fair to assume independence. Things like a pair of dice, things like cards, a spinner, a coin. Flipping a heads isn't going to change the probability of getting a tails the next time. So things like that are inherently independent. What about sampling without replacement when it can't be avoided? This is where the 10% condition comes in. So basically, sometimes you have to pick from a population where it doesn't make sense to replace, and I can't necessarily go out and pick a ton of people. I'm still going to pick a small sample, so your probability is slightly changing. But if you are going and selecting from a large enough population, the 10% condition says that we can act as if the trials were independent. Basically, the 10% condition is saying that our sample size has to be less than 10% of the population. So usually when you're taking out more than 10% of the population, your probabilities are going to alter from that large population. Think about males and females. If we say the population of the United States is 50-50, if I take out 5 males from the population, that's not going to necessarily change the 50-50 percentage. It may eventually change it if I took out 500,000 males. It may alter the probability then. That's when we start to worry. But just taking out a few isn't going to make a big difference in the overall percentage. So trials were independent. Now, for the N, this is the part that specifically makes it binomial. You need to have a fixed number of trials, and you want a specific number of successes. Now, same probability kind of goes hand in hand with the independence condition. Basically, you don't want that probability to alter based on something that has already occurred. So these are the 4 things we're going to check for. Most of the time, you're just kind of doing the check yourself. Sometimes they ask you to show that it is a binomial distribution, and that's when you kind of write these 4 things out, which we'll do in our first example. But usually, that's not a very common question. So let's go in, let's talk formula. So a couple of things to note. I went in, the formula that you get on your formula chart is actually written very big on your paper. But basically, you want to go in and you want to take the total number of combinations that result in your specific successes. And you want to calculate how many of those there are. So n, not a fraction, n choose x is a combination function. If you remember back in geometry, you probably did something like this whenever you were in your probability unit. Basically, in your calculator, there's something called NCR. This is something that we use to find these values. There is an actual formula that kind of goes along with calculating combinations. If you wanted to, you could use this. However, if you're going to your calculator anyway to do a factorial, you might as well just use NCR. But basically what this does is it calculates all of the possible combinations that result in getting this many successes out of this many trials. So the formulas that you kind of get on your formula chart, I'm going to highlight specifically just because there's so much going on right now. I'm going to highlight on formula chart. You get this one. And the nice thing about this section of the formula chart is that it is labeled binomial probability. So if you know that you're supposed to be doing a binomial probability, you just go to where it says that, and this formula is right next to it. The other things that they give you the mean formula, n times p, and they give you the standard deviation formula, square root np 1 minus p. So these are not things that you have to memorize. These are things that are on your paper. You don't have to worry about them. You do have to know what the variables mean. N is going to be your number of trials. P is your probability of success. And X is the specific number of successes that you're interested in. They don't label those on the formula chart, at least from what I'm remembering. But it's pretty intuitive after a while, after you've done this a couple times, what each one represents. Now, how this formula kind of works is you go in and you specifically want a number of successes. And so what you do is you think of all the combinations. You can put it on my desk, Henry. I emailed your teacher and said you were with me, so they should be okay. Yeah, put it on my desk. With the probabilities, you want a certain number of successes and you want a certain number of failures, depending on what number you're interested in. So we literally just plug into this formula. Now, the nice thing is our calculator has a way of doing this combinations. If you go to math, if you go to probability, It's like over, that's a really funky R. That's going to bother me. Probability. And if you go over like 4 times, you get to the probability menu. It is option number 3, and it should look like NCR. And you just plug in your number of trials, and your R is the total number of successes that you are after, and your calculator tells you what the number should be. So really, realistically, you probably won't use the formula a ton because there is a calculator function that takes care of this for us. But like I've mentioned before, they are moving more and more towards asking multiple choice questions about which of the following would correctly calculate the binomial probability. So knowing how they work is just as important as knowing the calculator function, especially when it's a formula that's on your formula chart. That's a little more fair game for College Board to say, hey, we gave you the formula, you just had to plug in numbers, you should know how to do that. So let's go in, let's try one out and see how it kind of works. A company reports that 75% of emails it receives is spam. You have 25 emails in your inbox. Explain how the following situation follows a binomial probability distribution. So the first thing I like to do is I like to go in and kind of see what would my random variable be. And since we're talking about spam emails, this would end up being the number of spam emails. So I'm going in and counting. Remember, a random variable is your outcomes from random events. I'm going in and I'm counting how many of these emails end up being spam. So then I'm going to go in and I'm going to check, is it binary? In our case, it is. It's either spam or not spam. I'm going in and checking, is it independent? And for the most part, things that you do that are kind of inanimate objects, in, for instance, an email, they work independently. You getting one spam email isn't going to increase or decrease the probability of the next email coming in being spam. So we can say emails are independent because they are. They're not influencing each other anyway. And then we're going to go in, N is your fixed number of trials. We have 25 emails that we are considering, and S is your same probability. Our P is going to be 0.75. There's a 75% chance that all of these emails become spam. So if all 4 things kind of check all of your boxes, this ends up being a binomial distribution. Now, if a question asks you to verify that something is a binomial setting, they literally are just asking you to check for these 4 things and have something to say about it. So all 4 things makes it binomial. So now we're going to kind of get into some of the other questions that happen quite often, your mean, your standard deviation, and just a regular probability interpretation. So first for mean, it's pretty easy. You're going to have the formula. It's N times P. You take your sample size, 25. You take your probability of success, 0.75, and you should be getting 18.75. And this is 18.75 spam emails. And so one thing that I would make sure you familiarize yourself with is how to interpret a mean and how to interpret a standard deviation. So in our case, if we were to select many, many random samples of 25 emails, I always include the sample size, because if I don't, this mean could be different if I was only taking a sample of 20 or 30. So this particular number that I'm getting is dependent on the fact that the sample size is 25. And so we would expect about 18.75 spam emails on average. And for my people who always ask me, what word do I have to have? You have to have expect. Remember, in stats, you don't want to ever say that something for sure is going to happen. So we always say that we predict it to happen, we expect it to happen, we believe that it should happen to be this, but it's not for certain going to be this every single time 100%. So that's one of the words that you want to make sure you include. For the standard deviation, it is going in standard deviation of x, square root, NP1 minus P. I'm going to go in square root 25.75. You can write 1 minus 0.75, but I'm just going to write 0.25 because that is what 1 minus 0.75 is. And I'm going to get a standard deviation of 2.17 spam emails. Anytime you report a mean or a standard deviation, you cannot forget to include units, because especially when you're going to write your interpretation sentence, they have to have units for it to make sense. So if we were to select many, many random samples of 25 emails, the number of spam emails would typically vary from the mean of, I like to include the mean value again with the same reasoning as before. If my mean was anything different, this standard deviation would be different. So by about 2.17 spam emails. I tried to make these prompts as general as possible, with the blanks being what you would fill in for the context of the question. So anytime you see things that ask you to interpret mean and standard deviation, you can kind of take this and just plug in, what is my numbers? What is the context? What is my sample size? Now, for the last part, it is just a general calculation. Find the probability that x is equal to 15. Now, we said that x was the number of spam emails. So just to kind of put that into words before I find the actual value, the probability you get 15 spam emails in a random sample of 25 emails. That's kind of what I'm looking for when I say, what is the probability of x equals 15? So I'm going to go in, I'm going to fill in the formula. So it's going to be 25 trials. I want 15 successes. The probability of success is 0.75, and there has to be 15 successes. So I'm going to raise it to the power of 15. And I'm just plugging into the formula that we have at the very top. So if I have 15 successes and my total sample size is 25, that means I have to have 10 failures. Those two exponents always should add to the total number of trials. So 25 and 15, or 15 and 10 make 25. So once you have it kind of laid out, you go to your calculator, because that NCR, the choosing combinations, is not something that you can feasibly do by hand. So I'm going to open up my calculator. I'm going to go to math. It's right underneath the alpha button. If you go over 1, 2, 3 times, you should get to the probability menu. And then option number 3 should be the NCR. And so I'm going to put in 25, choose 15. Now, normally I just put in my problems after this, but I do want to show you that this number is really, really big. So there's over 3 million combinations where you get 15 successes. So again, not a feasible number to kind of work with on your own. So I'm going to take it in, multiply it by 0.75 to the power of 15, and then 0.25 to the power of 10. And it's giving me an overall probability of 0.0417. Now, just a little disclaimer, most things in this class I round to 2 decimal places. Usually, you saw my mean and my standard deviation, they were 2 decimal places. The only thing that I will always require is that when you're doing a probability, that you round it to 4. Now, if you're worried and you think, I'm not going to remember when it's supposed to be 4 and when it's supposed to be 2, you can round everything to 4 decimal places. But again, the reason why I push for 4 decimal places when it's a proportion, like a probability, is because usually if you wanted to convert this to a percentage, which I do if I'm going to have to interpret, having 4 decimal places as the proportion guarantees that you'll have at least 2 when it's a percentage. So the probability that you get 15 spam emails in a random sample of 25 emails is approximately 4.17%. So again, and I will have those directions on your test. It'll say all general rounding to 2 decimal places, but please round your probabilities to 4. But if you're worried and you're like, I don't know when it's a probability and when it's a number, just round everything to 4 decimal places to be safe. Okay, so this is by hand. Again, kind of like what we talked about last time. Not like the worst thing to do by hand, but the calculator does make it a lot easier. So there are 2 functions in your calculator that are going to be useful to you. There is a PDF function and there is a CDF function. The PDF is going to be looking for an exact value. The CDF is going to be looking for less than or equal to a value. So for the equal to, you're only interested in one value. That's all you're going to get. X is equal to 5. I only get 5. Now for the CDF, it's going to be less than or equal to one value. And these are kind of your 2 options for what you can kind of do with the calculator. Now, there will be binomial ones, there will be geometric ones. These are found in the same exact menu where we were doing normal CDF. So if you go to second vars, option A should be binom PDF, option B should be binom CDF. And you have to make sure when you go to pick this, you pick the right one, because the questions that it asks you once you get into both of these functions are exactly the same. It's trials, probability of success, and the X value, trials, probability of success, and the X value. The one specific thing that I'll mention about CDF, that X value is your last included value. So whatever is the last thing you want the calculator to include, that is what you're putting into CDF. So really your deciding factor for which calculator function to jump to is 1, you'll have to eventually decide, is it binomial, is it geometric? Today, for everything you do, it should be binomial. And then 2, you have to decide, is it a PDF or is it a CDF? Now, one thing you might notice is CDF only does less than. So if I want to go in and I want to do, for instance, the probability that X is greater than or equal to 10, then I have to kind of work in complements. So what I would have to do is I would have to go in and do 1 minus the probability that X is less than or equal to 9. Because again, the only thing that the calculator can do is less than. So if I want to do greater than, it's still possible with the calculator. I just have to go in and remember that complements exist. So I just find the other side of it and I subtract it from 1. Another thing to kind of be careful about, to just point out here, if I instead had the probability that X is greater than 10, that would mean I'm not including 10. So I would go in and instead find 1 minus the probability X is less than or equal to 10. Because 10 is not included in that particular statement. One of the common mistakes that I see is I will see people who calculate the complement perfectly. They'll find X is less than or equal to 10, but then they'll still forget to subtract it from 1, so they don't quite get the exact answer that they need to. I will always go in and write the 1 minus before I even go to the calculator function. And I'll show you that when we get to one of those examples. But basically, you're probably going to be doing the calculator over the formula. So we're going to run through a couple of these. For example, 2 and 3, I picked specific questions because I wanted to match the wording on your math lab so that if you had questions, you could kind of reference this and get help. So we're going to go in. We have let X be the number of students that pass the AP Stats exam out of a class of 20. They told me I have a specific sample size. That is what makes this binomial. The probability that a random student will pass is 0.62. Find the probability that. So just to run through binomial again, it's binary. Either they passed or they failed. It's independent. One person passing doesn't affect the next person passing. There's a number of trials. We have 20, and we have a probability of success being 0.62. So all 4 of those things make this a binomial distribution. So now I'm going to go in. If I want the probability that all students pass, that means my X value would be all 20. Now, I'm going to write what has to be on your paper to get full credit on your test. This is an equal to. Anytime it's an equal to, it has to be a PDF. So just like normal CDF, we're going to require that you write out your calculator function. So again, if it is an equal to, it is a PDF. And then just like normal CDF, you have to label what you're putting into your calculator and you have to state what you're putting into your calculator. You don't have to tell me second bars. That is not necessary. But I need to see binom PDF. And then it asks you 3 questions. It asks you how many trials. We're going to say 20. It asks you the probability of success, 0.62. And then it asks for your X value, and we are going to say 20. So that is what you have to write on your paper. And then after that, you go to the calculator, you plug it in, and you're going to get your answer. It is not a ton of things that you have to write down, but it is the bare minimum of what has to be there. So I'm going to jump to my calculator really quick. We are going to go to second vars, and you should see normal CDF, one that we're familiar with. Inverse norm, again, we're familiar with it. I'm going to go all the way down to binom PDF. So that should be option A. Again, be careful which one you pick. Binom PDF, and yours should take you to a menu where it has prompts that you're going to fill in. Mine's, I just have to put it in exactly as is. So I'm going to have 20, 0.62, and 20. And I'm going to get a probability. Now here is where you have to be careful. Your probabilities have to be between 0 and 1. So if I see that I have a probability of 7, it cannot be a whole number. So immediately I go in and I look at the very end, and you should hopefully notice that it's going to have something like e to the negative whatever. That is how many times you have to move the decimal to the left. So when I write my answer, it's actually going to be 0.0000. I always at least go to 1 digit, and that's going to be 7. So 0.0007. And that is all you have to get full credit on an FRQ on your test. You don't have to show the formula. You don't have to write anything else. This is what you need. Okay, now to get into some of the wording, because we've done one, you've seen what it has to be. It's really not going to change much from this, but the wording of the question can be kind of tricky. If I say at most 15, does that include 15? Yes, it does include 15. So I'm going to say, because it could be 15 or less, the probability that X is less than or equal to 15. So when I go in to write this, it is going to not be a PDF, but since it's a less than, it can be a binom CDF. Again, anything that is less than can go directly into your calculator as is. And I'm going to have a trials 20. probability 0.62, and my X value is going to be, the last included number I want is 15. Now, they will take off points. I will take off points. If you just like accidentally write PDF for everything, if it's supposed to be a CDF, it has to be a CDF. Don't just rush through it and write the same thing over and over again. It has to be labeled correctly. The prompts for this in the calculator work exactly the same way. I'm going to hop over. I'm going to go to second vars. I'm going to go down to B, which is binom CDF. I have 20.62, and this time the last included value I want is 15. The nice thing about calculators, the TIs themselves and not my app, is that it should save your information. So it should still keep your trials, your probability, and you're just altering the X value to be what you need it to be. In this case, I got a probability of 0.9274. Again, any probability that I get, I generally take it to 4 decimal places. In the event that it has to be converted to a percentage, it's also just kind of nice because sometimes these probabilities are really close to each other, and we want to make sure that we are getting the exact correct answer so that College Board doesn't have a say in whether they can mark it right or wrong. So we have 0.9274. Okay, if I say no more than 6 students, does that include 6? Yes, it includes 6. So no more than 6. It can be 6. It just cannot be more than 6. So that is going to be the probability X is less than or equal to 6. A lot of what you'll find is that these questions, you really just have to think about, do I put the number there or do I not? The calculator function itself isn't hard. You're not really thinking a ton about it, but the hard part of it is going to be the English language and knowing whether to keep it in your answer or not. So my X value is going to be 6. And I would go through these steps exactly the same way. One thing that you can do just to show you is if you've done one and you just need to change the number, you can always do second enter and it'll kind of bring up what you just had. And you can just go in and I'm going to change it to be 6 this time. And I'm going to get 0.0037. So yes, you can always go through second vars and find it. But if you're really just changing one thing, I will sometimes just do second enter and call it back and change that number. The only thing to be careful of is if you're jumping from PDF to CDF, that's going to play a factor in whether you can use the exact same prompt or not. So I have 0.0037. So B and C kind of did the same thing. D is the one that's a little bit different. If I say at least 12, does that include 12? Yeah, it includes 12. So the probability at least 12 means I want 12 or more. So I'm going to say X is greater than or equal to 12. Now this is one where the calculator itself can't just do this as is. So what I have to do is I have to think, okay, well, I'm going to have to work in a complement. So I'm going to have to find 1 minus the probability of something. Now, if you're someone who struggles with, okay, what does that need to be? I will sometimes just suggest writing out a number line. It doesn't even have to be a big number line. It just has to be a couple numbers where you go in and you say, okay, I want 12 or more. Like that is what I'm interested in. So circle what you want and then look for what can I actually find. I can go in and I actually can find 11 or less. So the complement of 12 or more is X is less than or equal to 11. So that's going to be the other side. Now, generally, for the most part, my people who are like, can I just subtract 1? For the most part, it works. The only time you have to be careful is if you get into these situations like the right-hand side where it's X is more than 10 and it's not including 10. That means that I'm doing X is less than or equal to 10, which is different than just subtracting 1. So kind of pay attention to the language. Usually number lines help because you can just pick what you want to actually do and work with the complement. From here, I would go in and do 1 minus a binom CDF, trials 20. Yes, before I get my complainers, you do have to write it every single time, unfortunately. And the last included value is 11. Even if it's the same thing 4 times in a row, you write it all 4 times. Now, here's my piece of advice, because again, one of the sad things that I see all the time is I see correct calculations for the complement. However, not everyone, a good chunk of people forget to subtract it from 1. So what I usually do is when I go to my calculator, before I even call up binom, I'll do 1 minus so that I don't forget to do that. And then I'll do second vars binom CDF. And then I'd have 20, 0.62, and 11. And then I get 0.6659. So I make sure that I have the 1 minus there so I don't make the mistake of not subtracting it from 1. So this is going to be 0.6659. And again, if it doesn't say to interpret or describe in context, don't do it. Just get your answer, move on. But if you had to interpret, it would follow the same kind of setup as we did on the first example. So to go through some more questions that I saw on MathLab that might give you some pause, we have a new setting. Suppose the probability that any random freshman girl will agree to try out for the RHS Desperados is 10%. Same probability. And one of the team captains asked 25 random freshman girls to try out. That's my number of trials. Binomial, binary, it's going to be try out, not try out. Independent for the most part. They're going to be independent brains that think of if they want to try out or not. And then we have our number of trials and our same probability. So what is the probability that none of the freshman girls try out? So that would be a probability that X is equal to 0. Anytime it's equal, it is a binom PDF. And so I have trials 25, probability 0.10, and my X value this time is going to be 0. None of them try out. So I go to my calculator, I go to second vars, I go to binom PDF. I usually, when I'm actually doing this myself, I just go up because it gets there faster. 25, 0.10, and 0. And I get for this 0.0718. So about a 7% chance that none of the girls try out. Now for part B, this is another commonly missed question. What is the probability that at least one freshman girl will try out for the RHS Desperados? So if I go in and I do my at least one, the easiest way to find at least one is 1 minus the probability of none. Because think of all of those combinations from the first example. If I wanted 15 successes, there's 3 million possibilities, and that's just for 15 alone. At least one is 1, 2, 3, 4, 5, all the way up to all 25 trying out. So you don't want to feasibly have to sit there and think about all of those possibilities. Find the one instance where it's not true. That's none of them trying out. So if I want the probability that X is greater than or equal to 1, I need to be finding 1 minus the probability that X is equal to 0. None of them trying out. And conveniently enough, we have already found X is equal to 0. We said that that was 0.0718. And if you have done the work in another part of the same question, you don't have to show it again. I got this from part A. I don't have to rewrite binom PDF, all of that stuff. I can just say it's 0.0718. And so this probability is 0.9282. And what I'm going to have you do is I want you to write really big, because you will probably reference this at some point between now and your test. I want you to write really big, at least 1. So if you have to go back and figure out how to do this, this is a really good example of trying to tackle a problem like that. Going in and finding 1 minus the probability of none. Okay, another common question that I got from this particular math lab homework was, what is the probability that 10 or 11 freshman girls try out? Well, whenever we did ORs with basic probability, it just turned into the addition rule. Same thing's going to apply. We're going to find the probability that x is equal to 10 plus the probability that x is equal to 11. I truly don't actually write a combined statement for these. I just write them separately. I think writing them together would just get too complicated, x equals and ORs and whatever. No, I just write them as 2 different things. They're both equal to, so they'll both be binomial PDFs. And I'm going to have trials be 25, probability be 10, and my x value for the first one is going to be 10. And then I'm going to add that to binomial PDF, trials 25, p.10, x value is going to be 11. And I got questions of, well, could I just use CDF? CDF is counting everything below. So if I wanted it to be 11 or below, it's going to count 11, 10, 9, 8, 7. It just doesn't stop where you tell it to stop. So I actually have to find these separately. Now, I go to my calculator, I plug it all in. You do actually get something kind of weird. If I go in second vars binomial PDF 25.10, 10, I actually just add them together in the same line. You can do it separately and add them together. It doesn't make a huge difference in terms of the math. Binomial PDF 25.10, 11. It's another one of those where I'm getting a whole number, so you have to pay attention to the numbers at the end. This actually is a 7.7, which when I write my last digit, I'm going to round it to an 8. So it's going to be 0.00008. And the last thing to kind of wrap this up, again, with commonly missed questions that I get, or like commonly things that people ask me about. If you are selecting 25 freshman girls, how many do you expect to try out for the RHS Desperados? If you see the word expect, all you need to be doing is finding the mean. A lot of people get caught up on this question and they think they're supposed to be finding a probability and they're supposed to be doing binomial because they've been doing binomial for all of the questions. All they want you to do is find the mean. So the formula is n times p. So I have 25 times 0.10, which is going to give me 2.5. Now, the only time we would round these to whole numbers is if they asked us to. Keep it as a decimal. I know it seems silly that there's 2.5 of a girl, but we're going to keep it at 2.5. So if I wanted to interpret this, if we were, and I'm following literally the same exact prompt, if we were to select many random samples of 25 freshman girls, because again, this is specifically for that sample size, 25 freshman girls, we would expect, again, making sure I include that word, about 2.5 girls to try out for Desperados. And that, for the most part, follows that prompt that we did on the first example pretty closely. All I did was go in and I changed a couple things. I changed what my sample was, the 25 freshman girls, and I changed the value and the context. So that's all you have to adjust when you're going in and you are doing an interpretation for me. So now we have, now we have time